Hey everyone, today we're going to do a lesson on quadratics. So as just a reminder, we're going to just go through a couple characteristics of quadratics. So quadratics, let me write this here, are in a certain form, and in general, the most standard of the forms, which is called standard form, looks like y equals ax squared plus bx plus c. Now a, b, and c are just numbers. The only restriction on this is that a cannot equal 0. And the reason is because if this was equal to 0, this whole term would equal 0, and our x squared would disappear. And that's kind of what makes this a quadratic. So we can't get rid of that. So a cannot be equal to 0. Another thing about quadratics, let me just grab a different color here, is that there is a square in the formula. So they call this, it's a degree of 2. Degree of 2. That just means that the highest power or exponent that appears in the equation is 2. So it's a degree of 2. And the last bit is that, let me just draw a quick little sketch here, is that another color, oops, I didn't get another color. Let's see if I got purple here, there we go, is, wow, it's hard to draw with this. Let me undo that for a sec. Is that they have a certain look to them, and they are in fact curved. So this is what it looks like graphically, and we call this parabola. They curve in a certain way. There's a lot of different types of curves that we will eventually learn about, but this one is called a parabola. So just continuing on, I have a graph that I use technology. I actually use Desmos on the website, not the app, to make this graph. And this graph is just the most basic of all parabolas. And we can write this in an equation as y equals x squared. And the reason I'm looking at this is because I just want to make note of a few different characteristics. The first one is that there, as we know, there's symmetry to a quadratic. So there's like a line here that each arm kind of gets mirrored across. So it looks exactly the same on either side, just mirrored across this y-axis here. This is our, oops, I'm off my tablet here this is the x-axis. So this specific parabola has an x-intercept. It's actually right down here, touching 0, 0. And in this one, the y-intercept is also at 0, 0. And it has a line of symmetry that goes right through the y-axis. And we can write the axis of symmetry, I'm going to write here, axis of symmetry as, and it looks kind of funny, but we write it as x equals 0. So this is actually an equation of a line, not a value of a point. This is an equation of a line that just says that no matter what the y value is, because y is not in there, x is always 0. So if my y value was at 1, x is still 0. I didn't move right or left. If my y value is at 3, x is still at 0. If my y value is at 7, x is still at 0. So this is this axis of symmetry here, and that's how we write it as x equals 0.